History Unit 3, Chapter 8, Sugar, the simplest of carbohydrates. Carbohydrates are a major source of energy for humans. They provide 55 to 80% of calorie needs. They're a reserve energy storage in the body. They're part of the structure of living cells, and DNA has a carbohydrate component. So I usually ask in class if people remember what the D in DNA stands for. That's the carbohydrate parts of DNA. It's deoxyribose, and that ose ending is the indicator that that's the sugar. Carbohydrates are made of the elements carbon, hydrogen, and oxygen. The name itself means hydrate of carbon. It's carbon bound with water. Plants convert solar energy into glucose. That's photosynthesis. Glucose can be converted into fiber, which you see in the stems and leaves, and then sugar or starch as the plant matures. Seeds of plants that begin to grow, their carbohydrate is mainly sugar, and this is why baby corn and petite peas will often be sweeter than the full-size plants that you eat. Sugars provide a sweet flavor. They provide 4 calories or 4 kilocalories of energy per gram of food that you eat. Saccharide is the chemical name. Sugar is the common name. Carbohydrates are organic compounds because they are carbon-based. Monosaccharides means there's one basic molecule. Mono means one. So these are your simplest sugars. Examples are fructose, right here. You'll see this in fruits and honey. Glucose, that's your blood sugar, but you can also find it in foods like grapes or corn. Galactose is one of 6 basic sugars in milk, but galactose is only in animals and humans. Carbohydrates are often ring structures. They're often 6 carbon structures, like C6H12O6. This is glucose right here. This ring structure means the ring is a ring of carbon. So it's just a simpler way of writing sugars. Instead of writing all the C's, you create this ring structure. Disaccharides are 2 monosaccharides combined. These are the most consumed sugars in the world. An example would be sucrose, right? That's your table sugar. So that is a combination of glucose and fructose, so they're connected together. Maltose is found in malted grain, so it's not very sweet. These would be 2 glucose molecules connected together. And then lactose, this is the sugar that's in milk. It's white in color and contributes to the color of milk. The 2 sugars combined are glucose and galactose. Lactose intolerance. Lactase is an enzyme that you have in your small intestine. Lactose intolerance is an inherited inability to produce the enzyme lactase. Now you need lactase for lactose or milk sugar digestion. So if you are lactose intolerant, some of your symptoms would include a sour aftertaste when drinking milk, gas, bloating, nausea, diarrhea, and flu-like stomach cramps and constipation. Now, lactase can be obtained in pill or liquid form and added to milk, and there are many dairy products out there that have versions with reduced lactose or no lactose at all. And if you're curious, you can find out some more information in this video, which I will post. Sugarcane. Molasses. This is the crude boiled liquid pressed from sugar cane. So you would find this in recipes for gingerbread or ginger snap cookies. It's this dark liquid that you see right here, and here is sugar cane. Brown sugar is cane sugar not completely refined. It's brown in color, and the taste comes from molasses. It's needed for additional coloring and flavor in recipes, but it does need to be sealed well when stored to prevent loss of moisture. This gets hard right away if you don't seal it, so the moisture leaves rather quickly. Granulated sugar, it's a crystalline substance resulting from further processing. All minerals, flavorings, and coloring agents are removed from the brown sugar. So this is your granulated sugar. Confectioner sugar. This is granulated sugar ground into a fine powder. Some cornstarch can be added to prevent caking during storage. There is a number on the package, and that indicates how finely the sugar is ground. So 4x would be used for cough drops and chewing gum. 6x would be used for cream fillings, uncooked fondants, and icings. 10x would be your finest icings and fondant fillings. If you want some more info, this video will be posted. Sugar beets. This is a source of sucrose. It performs exactly like sugarcane. It's just more economical to grow. Maple syrup. This is the concentrated sap of maple trees. 40 gallons of tree sap is needed to make 1 gallon of maple sugar. So this is why most of the pancake syrups on the shelves are only 2% maple syrup. The main ingredient is corn syrup due to the high cost of the real maple syrup. So sorry, your syrup is actually not quite maple syrup. It's just really, really expensive. So this has corn syrup as the main ingredient. Corn syrup. Corn syrup is composed of varying amounts of dextrose, maltose, and polysaccharides. High fructose corn syrup is the sweeter version. It's found in soft drinks, pancake syrup, candies, baked goods. Starch can be converted into sweet syrups using enzymes, and corn is quite abundant in the US. Processed food prices are kept stable because of it. Sorghum. This is a grass crop that looks like corn in the field. Sweet sorghum, it's grown for its sweet syrup that resembles molasses. Honey. This is the first sweetener that was used in food production. Bees extract invert sugar from the pollen of flowers. And this is really about 70%, 75% invert sugar and 25% water. That's what's in your honey. Isomalt. This is 1 part mannitol, 1 part sorbitol, 2 parts beet sugar. It liquefies at 310 degrees Fahrenheit, does not form crystals, colors easily, and remains clear. It can be blown and spun into many sugary creations, and chefs love it. So this is very particular for the food industry. So if you've never heard of this or haven't worked with it, you really have to be into this type of creativity, but it's super awesome. I mean, look at that. That is just awesome. So chefs love it. Okay, functions of sugars in food. Sweeteners, right? That's the major function. Preservatives. Water is drawn to sugar before bacteria, so bacteria will dehydrate and die. It's the only preservative needed for most candies, jams, jellies, and syrups. It's often a tenderizer. It often softens dough, and a good example is to compare the bagel versus the donut, right? The donut has more sugar and it's a little bit softer. Crystallization. Sugar dissolves in water, and it's used in the candy industry. You need a proper temperature and concentration of the candy for the best results, but you can create those crystals. Caramelization. Sugar is subjected to high heat and it turns brown. This is your crusts on your baked goods and toast. And then fermentation. This is the food supply for yeast that makes alcohol or bread. Okay, so great functions of sugars: crystallization, caramelization, and fermentation. Sugar in the human body. Simple sugars are consumed. The bloodstream absorbs them, and then it heads to the liver. Fructose and galactose, these are converted to glucose in the liver. It slows their availability to the body's cells and provides the supply of glucose the body needs. Glucose that's not used immediately is converted to glycogen. These are chains of glucose. 2/3 of the glycogen is stored in the muscles, and the other third is in your liver. Molecules are broken off from the chain as needed. During intense exercise, up to 1/5 of your stored glycogen could be used in 20 minutes. Sugars are needed for fat and protein digestion. Glucose is needed for brain function. It increases the release of serotonin, which is a brain chemical with a calming effect. This is why you feel sleepy after eating a large meal. Now, health concerns related to sugar. Added sugars. So if you look on your label, added sugars, right? These are added by the manufacturer, and this is what's associated with a greater risk of heart disease, stroke, and diabetes. Added sugars are empty calories. There is no nutritional value. Dental caries or tooth decay. Um, this is acid damaging enamel on your teeth. Bacteria live in your mouth, feed on sugars, and produce plaque. Plaque is that sticky substance on your teeth that you need to brush off, right? Teeth have no access to oxygen, so bacteria will release lactic, pyruvic, and acetic acids. This dissolves tooth enamel and destroys your teeth. This is where it says this acid damaging enamel on teeth. So the acid is coming from the bacteria. Sugary foods like candy, soda, cereals, along with carbohydrates that can stick to your teeth, like crackers, pretzels, certain candies, right? This is what damages teeth, right? So it's for how long they are on the teeth. So my dentist has always told me it's not necessarily how much you are eating, right? Which is a whole other separate issue. But in terms of your teeth, it's how long the foods are remaining on your teeth. Fluoride toothpastes and flossing help prevent cavities. Then there's also diabetes mellitus. The body cannot move glucose to the bloodstream and requires insulin. Insulin is a hormone produced by your pancreas, and it allows glucose to move into the cells for energy use. People with this form of diabetes cannot produce this hormone, so you cannot handle large inputs of sugar in the diet. So it is best to maintain a well-balanced diet throughout the day. You don't have to avoid sugar, you just have to manage it. All right, we also have adult onset diabetes. It used to be known as this or type 2 diabetes, but it's no longer just adult onset. It now occurs in children. The body resists the effects of insulin or can no longer make the hormone. So the body becomes resistant to insulin. Diet and lifestyle can create this in the body.